All right, so in this video, we are going to look at how we solve for either P of t, which is the ending value, and then alternatively how to solve for the starting value, P sub 0. So the first half we'll do solving for P of t, second half we'll do solving for P sub 0. P of t is actually really easy, so the idea goes like this. Let's say you have a situation, so a population of 800 is growing at 7.2% per year. What will the population be in 5 years? So we can set this up as a typical function. A lot of times what we'll say is, instead of P sub t, what we'll say is P of t. We'll make it into a function of t. So P of t, the population at the end is going to be equal to the starting value, which is going to be 800, times, normally it'll be 1 plus r, right? Okay, but in this case, r we can find. R is going to be equal to 7.2 divided by 100, which will be 0.072. Okay, and so we can replace r here with 0.072, and so that's what we're going to do. We'll put in a 0.072 to the power of t, because we do know the time here. The time is 5, but we're going to plug it in a minute, okay? So this is our exponential function, but I'd like to clean this up. I'd like to do 1 plus 0.072, which will be 1.072. So let's go ahead and do that. We'll clean this up a little bit. And when we add 1 plus 0.072, we get 1.072 to the t power. So this would give us any population given any time. But in this case, the time is 5 years. So here's what we do. We take our exponential function and we plug 5 in for t. So we're identifying what is P of 5. And P of 5 is going to be 800 times 1.072 to the 5th power, which this can just be, there's not really any algebra. There's no algebra that has to be done. All we have to do is just plug this into a calculator. So let's switch over to a calculator. All right, here's our calculator, and we're just going to key in 800 times 1.072 to the power of 5. We press execute. And we get 1132.567. Now, I would, we can go out to 3 decimals and do 0.567. So let's write that. Let's go ahead and write that in, 1132.567. All right, so 1132.567. But a lot of times populations can only be whole numbers. This 5, 6, 7, well, really the 5 is going to tell the 2 to become a 3. So really what we're going to say is that our answer is 1133. And so P of 5 is 1133, okay? And that's our final answer. That's if we're rounding to the nearest whole number. But if we're rounding to 3 digits, then it's 1132.567. So let's do another one like that. We've got $2,000 is deposited into an account that returns 4.7% annually. How much will be in the account in 500 days? Okay. Well, our function is going to be P of t, and it doesn't have to be P. It could just as easily be, M of t for money. Okay. The money at a certain time is equal to the starting value, which is 2,000. Times 1. This is a growth because we're returning, so it's growth. Returning 4.7% annually. So that's 4.7 divided by 100 to get our rate is 0.047. So it's going to be 1 plus 0.047, which is 1.047 to the power of t. And if we want to know how much money, and note that this is, sorry, I have to change this. This is 4.7% annually. This is asking for 500 days. So what we have to do here is I got to go back. It's going to be 1 plus, watch this. We actually have to convert an annual rate into a daily rate. And the way we do that is we take our annual rate, 0.047, and we divide it by 365, because there are 365 days in a year. And so this is a tricky one. So this is actually going to be 1 plus 0.047 divided by 365 to the t power. And because of this, I'm not gonna calculate it out. I'm gonna leave it just like this. Okay, this is gonna be my formula. So now if I wanna know 500 days, I wanna know m of 500, okay? And so m of 500 is gonna be 2,000 times 1 plus 0.047 divided by 365 to the power of 500, okay? Let me clean up that 5. There we go, 500, okay? All right, so this is money, so we're actually going to go to 2 decimal places for pennies, but let's go ahead and key this into the calculator, okay? So this is going to be 2,000 times 1 plus, and then 0.047 divided by 365, close parenthesis, to the power of 500. And I hit enter and I get 2,132.993. So really this is 99 cents. So 2132 and 99 cents. So this is money. So it's going to be $sign 2132.99. Now if you're told to round to the nearest whole number, you would do 21, it would be $2,133, okay? If you were rounding to the nearest whole number, okay? Now let's do this one. This says $3,000 grows continuously. Continuously means E. By 8.4% annually, how much value will there be in 15 years? We don't have to do a conversion here because this is a yearly rate and we're asking about years. So money over time is going to be, since it's continuously, our starting value is 3,000. So 3,000. E to the power of our rate, 8.4%. So we have to do 8.4 divided by 100 is going to be 0.084. And so it's growing, so it's not negative, it's not shrinking. So 0.084, okay, great. And with a t, okay? Now we want to know how much there will be in 15 years. So this will be m of 15 is equal to 3,000 e to the power of 0.084 times 15. We can just key this in a calculator. So it's going to be 3,000 e to the power of 0.084, and I recommend parentheses here, so I'm going to put a parenthesis in, times 15 years, and then close the parenthesis. Let's execute, and it's $10,576.26. 10,576.26. $10,576.26. And if you were rounding to the nearest whole number, it would just be 10,576. Okay? All right. I think that's all I'm going to do in this video. In the next video, we'll solve for the starting value.